Welcome. In this video, we are going to discuss about two kinds of meeting rooms. So, this is the first meeting room where 2D array is given. This represents starting time of the meeting and this represents ending time of the meeting. So, our task here is simple. We just have to check whether we can attend all the meetings or not. If we can attend all the meetings, you have to return true, or else you have to return false. So, in this first example, one meeting started 1 and end at 4. Another meeting started 10 and end at 15. And third meeting started 7 and end at 10. So you can see that all the meetings are scheduled at different time. So you can attend all the meetings. So in this case, the answer is 2. You have to return true. So and next example, meeting starts at 2 and ends at 4. Second meeting starts at 9 and ends at 12. And third meeting starts at 6 and ends at 10. So you can see these two meetings are clashing. So you can't attend all the meetings. So in this case, you have to return false. To solve this, it is simple. First, you have to sort the array and then you have to check the condition. So this is the code where you will sort the array first and then you will check whether ending time is greater than starting time or not. If this is true, you have to return false. That's it. Now, this is second kind of meeting room problem where start and end array are given separately. So your task is a bit different. You have to check how many rooms are required for all the meetings to be conducted. So here we have to return minimum number of rooms. So first you can see 1, 4, then 10 and 15, and 7 and 10. Here you can see that all the meetings are scheduled at different times. So only one room is sufficient. Now in the next example, you can see 2, 4, 9 and 12, and 6 and 10. These two meetings clash with each other. So you have to conduct meetings in two different rooms. So minimum number of room required in this case is 2. So how should we solve this? So one of the approaches sorting and tracking. First you have to sort both the array. So after sorting, we get start as 1, 7 and 10 and ending becomes 4, 10 and 15. So in this we are going to initialize three variables I, A and rooms. I keep it as just R for rooms. Okay. And initially A is 0 and R is 0. A is used to iterate to start starting array. I is used to iterate to ending array. So now initially I is 0. Now you have to check whether start of k is less than ending of I. If it is less, you have to increment k. Here 1 is less than 4. So you have to increment k. So k will be 1. Then you have to check again. Now 7 is greater than 4, so you don't need to increment anymore. And rooms is a minus I. A minus I gives total number of rooms. So now the rooms will be changed to 1. Next, I will be iterated to 1. And here start of k which is 7 and ending of I which is 10. 7 is less than 10, so you have to increment k. On the next step, you can see starting of k and ending of I both are equal. So in this case, you have to stop iterating. So k will be changed to 2. Now the value of room is k minus I, which is 2 minus 1. And, and this is the total number of rooms required, 1. Then at last iteration, that is at I equal to 2, you will check the condition. But you can't increment k further because Incrementing k would exit the array and you might get index out of bound error. So no, k will be incremented to 3, but it won't be furthermore incremented. So in this case, r will be 1. And this is the final answer. So for next example, first you have to sort this. 2, 6 and 9. And ending array also you have to sort it. 4 and 12. Initially k is 0 and r is also 0. I will get greater and then you can see 4 is greater than 2, so you have to increment k. Then start of k, which is 6. 6 is greater than 4, you have to stop iterating. And in this case, you can see r value k minus I is equal to 1. Now next I will be incremented to 1. Then you can see 10 is greater than 6, so you have to increment k. K will be 2. Next, you will compute these two, 10 and 9. Again, 9 is small, so you have to increment k. And you will get 3 as answer. And you cannot increment furthermore as it is, as, as it already reached its maximum length. So the r value in this case is k minus n, which is 3 minus 1. It gives 2. 2 is greater than 1, so you have to write 2. Next, when I is equal to 2, there is no change in k. K will be remain to same, and here k minus I will give you 1. But 1 is smaller than 2, so r value won't be changed. So this is the final answer for the second one. Now this is another approach to solve this problem. Basically it is same, but you have to pair them up. While pairing, you will get them as 2, 4, then 6, 10, and 9, 12. So you have to pair and sort them first. And then you have to use heap. Heap is initially empty, and you have to keep track of length of the heap. And initially number of rooms is 1, because minimum room required to conduct a meeting is always 1. So initially r is equal to 1. And then we have to keep iterating. So for this, 1 room is sufficient. And then you have to see ending time. Ending time you need to push to it. So 4 is pushed to it. Next, we have to iterate, and you can see 6. 6 is greater than 4. When this happens, you have to pop the element from the heap. Suppose if the start time is less than the ending time, then you have to push into it. But that's not the case here. So you have to pop the element. You have to pop, and then you have to push ending time, which is 10. And now there is no change in the length of the heap, so R will still remain as 1. Next, we'll go to this pair where 9, where the meeting starts at 9. So you can say 9 is less than 10. So you have to iterate, and then you have to push this, push 12. And now the length of the heap is 2. So you have to return, value of room, number of rooms required will be 2. So this is the final answer. This is the Python code for both the approaches, and both require you to sort the array. So because of that, complexity time complexity is big of n log n. You hope you have learned something new here.